Okay, in lesson 21, we had two different areas we were working on. First one was about how the product compares to the factor that's being multiplied. Okay, so let's take a look at question 1 here. And it's showing 1/3 times 1, and we know any times we multiply any number by 1, we'll get the same thing. And it's showing here that instead of 1, we're just using 3/3, which is still 1 whole. So basically, we're multiplying 1/3 times 3/3 give us 3/9, and that is just an equivalent fraction. So both these two are equal to each other. So let's look and see on B. We have 2/3 times 1, which we know is equal to 2/3. Now the key here is 3 times what equals 21, and I know 3 times 7 is 21. So 7, in order to make this 1 whole, has to be 7 sevens. On C, we're multiplying 5 seconds times 1. So 5 seconds times something equals 25ths. Well, I know 5 times 5 is 25. So 2 times 5 would be 10. So 10 25ths would be the answer. Now it says compare the first factor to the product value of the product. Okay, so what they're saying here is up here on A, we can say 1/3 compared to 3/9. So 1/3 compared to 3/9, they're going to be equal to each other. And we know that because we multiplied by 1. Now, on the second one, we have 2/3 and 14/21. Once again, we know we multiplied by 7 sevenths, which is equal to 1, so they are also going to be equal to each other. And the last one, which is 5 seconds and 25 tenths. Once again, because we multiply by 5/5, which is equal to 1, and anytime you multiply by 1, they are equal to each other. So that is the answer to D. Okay, we're going to be trying to create equivalent fractions, and we're going to be trying to create equivalent fractions with a denominator of 10, 100, or 1,000. And that's so that we can convert it directly over to our place value system, where decimals are 10, hundreds, and thousands. If we go up to A, we can see they've done 4 times 25 is 100. 3 times 25 will be 25. Now this says 25, actually that's going to be 75. 75 100ths. So I know 75 100ths, the 5, the last digit, has to be in the hundreds place. So when I write as a decimal, I'm going to make sure the 5 is in the hundreds place, and that's 75 hundredths. On B, we have 1 times 25, and we have 4 times 25, which is equal to 25 over 100ths. And once again, we know the 5 is going to be in the hundreds place. So when we write it, we got 0.25. The 5 is in the hundred place, 25 hundredths. The next one, we're trying to convert it, and what I tell the students is take a look at your denominator 5 right here. What times 5 will give me 10? Well, I know that 2 times 5 will give me 10. And since I'm creating an equivalent fraction, it has to be 2 seconds, which is going to give us 4 tenths. And the 4 has to be in the tenths place, so it's going to be 4 tenths. On D, once again, we're looking 5 times 2 is 10. And you're always trying to go to the smallest one. That's going to give us 6 tenths. And the 6 in the tenths place, so the first one is a tenths place, so it'll be 6 tenths. Now on letter E, we can see that 20 cannot be turned into 10, but 20 can be turned into 100. And the way we're going to do that is I'm going to multiply 20 by 5. And if I multiply 20 by 5 to get an equivalent fraction, I have to multiply the top and the numerator by 5, and I'm ended up with 15 100ths. Now that means the 5 and the 15 has to be in the hundreds place. So when I do this, the 5 goes in the hundreds place. On F, once again, I'm going to multiply by 5 to get 100, and that's 5/5, which equals 125 100ths, which I know the 5 goes in the hundreds place. So I'm going to put 125. In order for the 5 to be in the hundreds place, my decimal has to go here, because that's my hundreds place. Okay, I'm going to write down here again. We have 10, 100, and 1,000. And I can see 25 won't go into 10, but I can turn 25 into 100. And that's going to be by multiplying by 4. So 4/4. And that's going to equal 100 on the bottom and 92 on top. So now I have 92 hundredths. So when we write 92, in order for 2 to be in a hundreds place, it's got to be 0 and 92 hundredths. On H, 50, well, I know 50 times 2 is 100. So I'm going 2 over 2, and that's going to give me 100 on the bottom. And on top, it's going to give me 178. Let me think here. 178. So now I have 178 hundredths. Well, I know my place value. My hundredths place is right here, so the 8 has to go there. And the 7, that means the 1 is actually a whole number. So it's 1 and 78 hundredths. On 3. Now here they have mixed number, and it starts to confuse some students. So, but when our ultimate goal is to write this as a decimal. So in order to write 3 as a decimal, I'm going to write it as 300. My whole number is done now. Now I'm going to convert 11/25 to hundredths, because I know I can multiply them by 4 over 4, which will give me 44 100ths. So to write 44 hundredths, it'd be 0 and 44 hundredths. But I've got to add my 3 from my whole number, and now I have 3 and 44 hundredths. And the last one, same thing. I'm just going to rewrite the 5 as a whole number. Now I'm going to multiply by 2 to get 100. Now I'm going to have 82 100ths. So to write 82 as a hundredths, I'm going to go 0 and 82, because the 2 has to be in the hundredths place. I'll line up my decimals, add the fraction, add the decimals, and I've ended at 2, 8, 5, and 82 hundredths. Number 4. A number multiplied by a fraction is not always smaller than the original number. Explain this and give at least 2 examples to support your thinking. Okay, so this is the common scenario most students think. Let's say I had 5, and I multiply that by 1/3. That's going to equal 5 times 1 over 3, which equals 5/3, which equals 1 and 2/3. And you can see 1/3, 1 and 1 2/3 is smaller than the original factor. And this is what most students think, and they always say, no, anytime you multiply by a fraction, your product, which is 1 and 2/3, is always going to be smaller. Well, that's not exactly true, because what if I took 5 times 3/3? Well, 5 times 3/3, this is a fraction. So this is going to end up with 5 times 3 over 5, which equals 15/5, which equals 3. Now, if you notice, it may not be smaller, it is equal. And that right off the bat shows that this is wrong. Okay. Now the last one, we did one that was less than 1. We now did one that was equal to 1. What if we take and we do 3 seconds? So we end up with a fraction that's greater than 1. So we end up with 5 times 3 over 2, which equals 15 seconds, which equals 7 1/2. And you can see this fraction was larger than the original factor.